Okay, in this video, we're going to talk about adding and subtracting vectors graphically. So let's say we have some vectors here. We'll say that this is vector A to be defined on this grid here. We could define this with a magnitude and an angle theta along here, or we could define it with its components. It's ax and ay, it's x and y components. And then let's say we have another vector. We'll say that vector b looks something like this. There's vector b, and then let's say that vector c is a vector like this. This is vector c. And we have vector b right here, and vector A in blue there. If we want to add these, if we want to find the vector sum, then I will call this the resultant vector. So R, the vector R, the resultant vector, will be the vector sum A plus B, vector A plus vector B plus vector C. And we'll add these together. Now note here, or remember that just because vector A is defined at the origin doesn't mean that it has to start at the origin. We could have vector A, let's see, it goes over 1, 2, 3, and up 1, 2, 3, 4, 5. This would be the same vector if we started right here, over 3 and up 1, 2, 3, 4, 5. This would also be vector A. It doesn't necessarily have to start at the origin. So the fact that A, B, and C, I drew them at the origin was just for simplicity to define them. Easiest to read the coordinates just off the grid when it's defined this way. If I want to add them together, we can think of vectors as kind of like the way we would walk. It's a prescription for motion here. And so if we want to add them together, what we would first do is we would start with vector A. We would travel along vector A here, like this. And once we reach the head of vector A, we could then add on vector B. So it's like we walk to the end of vector A, and then we start walking in the direction of vector B, to walk along B. So what we would do is we would place vector B at the head of vector A, and vector B moves to the left 1, 2, 3, 4, and moves down 1, 2, 3. So we'll do the same thing here, over 1, 2, 3, 4, and down 1, 2, 3. So vector B would take us from the end of vector A to over here. So this is vector B, our motion there. And then vector C, we would start at the end of vector B, and we would move, since vector C was defined to be to the right 2 and down 2, that's exactly what we'll do to move in C. So moving to the right 2 and down 2, we have something like this. And the resultant is where we end up. So the resultant actually ends up being pretty small here. The resultant of this vector is from the start of the first one to the end of the last one. If we didn't know the path, then we wouldn't know that we walked all the way up along A, then back down B, then back down C to end up here. It would have been the same thing as just moving over 1 unit to the right. So we could say here, just looking at this, from our graphical sum, we could say the resultant is equal to, it moves over 1 in x, and it doesn't move at all in the y direction. This is our vector sum. This is how it moves here, just 1 in x. We could have also added it in a different way if we wanted to. Vector addition is commutative. We could have said this is the same thing as, let's say we do vector b plus vector c plus vector A. We'll end up with the same result. Let's do that here. So vector B, we'll start with this one, and let's start out over here. So vector B will move 4 to the left, 1, 2, 3, 4, and down 3, 1, 2, 3. So vector B is right here, move that way first. And then we are going to add in vector C. So vector C moved 2 to the right and 2 down, so it'll move us over here. This will be vector C, adding onto it now. So now we have B plus C. And lastly, adding in vector A, which moved 3 to the right and 1, 2, 3, 4, 5 up. We'll move from the end here, 3 to the right and 5 up, 1, 2, 3, 4, 5. And vector A takes us to right here. The resultant of this is from the starting point of the very first vector to the ending point of the last vector. So this is our resultant vector here as well, which you see that it's exactly the same as the resultant that we came up with adding A plus B plus C. So vector addition is commutative. If we wanted to subtract vectors, then let's give us some new vectors here. Let's say we have vector A is something like this. We use a different vector here. Vector B, we will say, here's vector B. And then here, let's say we have a vector C that looks something like this. Here's vector C. So let me label these. Vector A, vector B. Vector B is meant to be horizontal there, and vector C is right here. Now let's say we wanted to do our vector difference. So we'll call this vector D for difference instead of the resultant vector sum. So the difference vector, we'll define this. Let's just say this is A minus B, vector A minus vector B. Now subtraction is actually just addition of a negative, right? So vector D is really vector A plus negative vector B. And when we have a vector that is negative of another, we say this is anti-parallel. This is anti-parallel to vector B. And so vector B here, I wanted it to stop right here. So vector B was just simply 1, 2, 3, 4 to the right. So vector negative B would be 4 to the left. 1, 2, 3, 4. This would be vector negative B, which is the same magnitude. It lies along a parallel line, but it is in the opposite direction. It points to the left as opposed to the right. So that's vector negative B. So if I wanted to do A minus B, this is A plus negative B. So adding this up graphically, we could start out with vector A up here. And then from the head of vector A, we will move along vector B, or vector negative B, sorry. So vector negative B would move us 4 to the left, 1, 2, 3, 4, and it would move us over this direction. That would be vector negative B. So our resultant is then, let's see if we have another color here. Our resultant would be from the beginning of the first one to the end of the second one. This is the vector difference, vector A minus B. And so you see here graphically, the vector difference is going to be equal to, it moves to the left 1, 2, 3, and it moves upwards 1, 2, 3, 4. So this is negative 3, 4. If we had more vectors, we could just add them in, or add their negatives if we are subtracting them. So for instance, let's say that we wanted to do let's say we have another vector. I'll call this vector E. Let's say vector E is going to be equal to vector B minus vector C plus vector A. So this is vector B plus negative vector C plus vector A. So I'm just going to draw all these down here. Again, yeah, this is commutative. Addition is commutative. We could have started with negative C plus B plus A plus negative C plus B, etc. So starting with vector B, and I'm just going to start down. I'm going to start right here. Vector B is 4 to the right, so 1, 2, 3, 4. Here's starting out with vector B. And then vector negative C, well, C is down 1 and left 2, so vector negative C is up 1 and to the right 2. So this is vector negative C. So then moving now along vector negative C, up 1 to the right 2, here's negative C. And then now adding in vector A, a positive of vector A, which was right 1 and up 1, 2, 3, 4. So right 1, up 1, 2, 3, 4. And we have, this is vector A added on. And so the resultant vector here is this one, where we start at the very beginning of vector B and we end up at the end here of vector A. This is vector E graphically. So we'll actually, let's get some units here, or give this actually in vector form. We can express all of these vectors, I'm sorry, not in vector form, but in component form. We can express all of these either with magnitudes and angles, or in their component form. So vector E, we just label how it moves. So it starts here, then it moves 1, 2, 3, 4, 5, 6, 7. It moves 7 to the right, and it moves upwards 1, 2, 3, 4, 5. So vector E is 7, 5. And that's graphical addition of vectors. So it's just the thing to remember is it's like it describes the motion that you're undertaking, and you just kind of walk to the end of the first vector, and once you're at the end of that one, then or the head of that one, then you just walk along the other vector, and you continue doing this until you've added them all up, and the resultant is just from the start of the first one to the end of the last one.